Hey guys, welcome back to YT Classroom. I hope you all are doing good. So today we'll be looking at IGCSE Computer Science Paper 1 Variant 2 from Feb March 2024, which is again the paper that has been from the 2023 syllabus, which has some significant updates. So do stay throughout this video. I'm gonna be solving the whole paper and also give you some tips to how to answer the questions. Alright, let's begin. If you're new to this channel, please make sure to like this channel, comment if you have any doubts or any suggestions to the video, and also subscribe to the channel, share this video with your friends. Alright, now we move on to question number 1. So question number 1 is an MCQ question which says that computers represent different types of data in binary. Take one box to show that why computers use binary to represent data. So option A says that computers only allow ones and zeros to be entered. This is definitely wrong because it means that can you enter only 1 and 0? You can enter any number and any data that you want. Computers are made of switches and gates that can only be on and off. So this is correct because all computers consist of certain types of transistors, which are essentially switches that can either be in an off position or an on position. I'll let the other two options as well. Computers does not need to be binary, does not need to be converted into the forms of data to be displayed. Binary does need to be converted into the forms of data in order to be displayed. It does need to be. Both computers and humans can process binary data. Humans cannot actually quickly process binary data. So hence the correct option is basically option B. Alright, just marking it here as well. Then it says that one form of data is characters. The American Standard Code, the ASCII code for letter N is 78. Take one box to find the ASCII code for Q, denary ASCII code. So it's just an order, so M, N, O, P, and Q. So if N is 78, this would be 79, this would be 80, and hence this would be 81. So option A is correct. Then it says that give the binary number for the denary number N. So we have to get the binary number for 78. So if you just mark it down here, 128, 64, 32, 16, 8, 4, 2, 1. Then you put the number is 78. So here we put 1. Now 64, 78 minus 64 would be 14. 14 minus 8 would be 6. 6 minus 4 is 2. And 2 minus 2 is 0. So that shall be it. If I just add them up, 64 plus 8, 72, 76, and then 78. So 0, 1, 0, 0, and 1, 1, 1, 0. Alright. Then it says explain how the word is represented, where it is represented in a character set. So we say that each of the characters means that each of the characters R and E and D. Each of the characters has a unique binary value, has a unique binary value which is looked up on an index file. So once you have looked them up, then we say that first the code for red is stored. First the code for R is stored, followed by what are the two letters E and D. So E and D in sequence. Alright, so I hope this makes it clear. The basic process is that each character has a unique binary value. You have to look that up, which is in an index table, and then you assign it and then store it in the order. Then it says that sound can be represented binary. Explain why recording sound with a higher sampling resolution gets a more accurate recording. Now for this is a 2 marks question. So we'll start with writing then higher sampling resolution means more bits are allocated to each amplitude value. More bits are allocated to each amplitude slash the sampled value. Hence, they are more likely to be closer to the hence. They are more precise and more closer to the hence they're more precise and more closer to the original, leading to more accurate sound, more accurate recording. Alright, so basically, okay, let's read the next part, which says that give one of the ways the accuracy of sound recording can be improved. This would be increasing the sampling rate. Increasing the sampling rate. So basically, whenever you're talking about representing sound files, there are two things: there's sampling rate and sampling resolution. So the sampling rate is the number of samples that you take in a second, and the sampling resolution is the number of bits that you use to represent each of the sample values. So when you use more bits, it allows more, like the range of linear number that you represent increases. Hence, the value of the amplitude would be more closer to the original compared to the sampling rate, compared to the original without less bits. So I hope this question is clear. Now let's move on to the next question, which I think is question number 2. It says that a computer has a CPU and the registers are given. The table contains 5 statements about the role of the registers. 2 are incorrect and we have to identify them and you suggest the corrected statement. So let's go through each of the statements. It says that PC stores the address of the next instruction to be assessed. That's correct. So A can't be A is correct then. B, MAR stores the instructions to the program that is running. Now this is wrong because MAR, memory address register, actually storing the addresses and not the instructions. So we need to correct B. So that's one thing. C, MDR stores the data passed to it from the PC. No, MDR actually stores the data that has been passed to it from the data bus through the memory. The PC only has the instructions. That's not, so we need to correct this as well. We have found two, but let's just check the other ones. Accumulator ACC stores the result of the calculation. That's true. And CIR, current instruction register, which by name you know that it stores the instruction currently being executed. So we would say that the incorrect statement is basically B and C. The correct statement for B would be that MAR stores the address of data that has just been read from memory, or that is slash about to be written to memory, not the instructions. Next up we have C, for which would be that MDR stores the data passed to it from the data bus. MDR stores the data passed to it from the data bus. Then it says that a computer has a single core 3.5 GHz processor, gigahertz processor, and 8 KB, 8 kilobytes cache. State what is meant by 3.5 gigahertz processor. It executes, or it carries out 3.5 billion FDE cycles, which are basically fetch, decode, execute cycles each second. Alright, so I hope this is clear. It carries out 3.5 billion FDE cycles each second. The CPU is now changed to a dual core. So before just a single core, now we have a dual core CPU. So how will the dual core affect the performance of the CPU? That's what we are being asked. Now, in order to answer this question, I would start off my answer by saying that one core can process one instruction. One core can process basically one instruction each second. Two cores can process multiple, because if you have two, you can process multiple instructions multiple instructions simultaneously. Hence twice as many instructions will be processed. Hence twice as many instructions will be processed each second. Will be processed each second, improving the performance of the CPU. Improving CPU's performance. I hope this is clear. So what I've basically said here is that if one core allows you to perform one instruction second, so multiple cores allows you multiple instructions, so basically two instructions. Hence you process twice the instructions because having two cores, hence your performance improves. The amount of cache is now increased to 64 kilobytes. Explain how the amount of cache affects the performance of the CPU. For this, cache is used to store frequently used data and instructions. Frequently used data and instructions. By having a larger cache, processor will be able to access the data faster, By having a larger cache, you can access the data faster, as access time to cache is less than RAM. Hence performance improves. So what I've basically said here is that now the first thing you need to understand is cache is directly located inside the CPU, which is closer than the RAM itself. So the access time is likely to be faster. And cache basically stores the data and instructions that are required for almost every application. So once you have more of this data, the C processor will be able to access this data faster, and it avoids accessing the slower RAM, which is a bit farther away. Data access speeds up, so your process also speeds up, hence the performance is actually improved. The computer has both primary and secondary storage. Random access memory is one example type of primary storage. Describe what is meant by RAM. Now remember, it's a 2-mark question. You can't get marks for writing random access memory primary since they're given. So you could say that RAM is a volatile storage. A volatile storage basically means that when you turn off the computer, the data in this is lost, which is used to store data, instructions, and parts of operating system and parts of OS that are currently running. Parts of OS that are currently running. It says that ROM is another type of primary storage. ROM often stores the startup instructions. You have one that is stored in the ROM. You have startup instructions and you have your firmware. You have firmware which is stored in ROM. Now, firmware is basically a program that provides low-level control for devices. Some computers make use of virtual memory. State the purpose of virtual memory. Virtual memory allows more data to be stored more data to be stored on the RAM than its size whenever required. So basic whenever required. So virtual memory is a type of program that basically allows you to store more data on the RAM than its storage capacity. How does it do this? Is basically that the certain sections of the data that you not need. Let's say you want to keep 5 things in the RAM, but currently you can only keep 4 things. You have 5 things you want to store, but you have only space for 4. So one of them will actually be stored in the hard drive, and whenever you need that thing, it will be swapped for something that you don't need in the RAM, thus allowing you to store more data. And hence you can avoid accessing, having to buy more RAM. Now we'll move on to question number 3. Now we will be moving to question number 3, which says that a computer has an operating system. Complete the table by writing each missing OS function name and description. Now, managing memory, the description I would write for managing memory, as far as the point I remember right now, is basically to prevent two processes from accessing the same memory. Prevent two processes from accessing the same memory location. Then allows application software to run on the computer. To allow the application software to run on the computer, what is it called? It's basically called as platform for running applications, or you can also write platform for running application software. And then platform for running applications, because here asking for the function. Managing peripherals involves transmitting data to the hardware, which I think is a simple thing to write. It's only 3 marks, so 1 point per each would give you the marks. The OS handles interrupt. State the purpose of an interrupt. An interrupt is basically indicates that something like a process or a software to click requires the attention. Something requires the attention of the processor, which then uses the ISR to resolve it of the processor. Give a name of an input device, an example of an interrupt can generate. I would best write as a mouse. I think you can write the keyboard as well, and as well as a mouse button click. When you click the mouse button, generates an interrupt. Alright, then it says that the processor is currently executing a program, it receives an interrupt. Explain how the manages the current program interrupt. So first of all, what the processor will finish the fetch execute cycle the processor will finish the fetch execute cycle for the current process. The processor will finish the fetch execute cycle for the current process. Now, after you finish the fetch execute cycle for the current process, then it will then check the interrupt priority queue, the interrupt priority queue, to basically see that is this the highest interrupt which needs to be resolved, or is this the most prioritized interrupt. It will then store the data on the registers for the process on a stack. Now this is basically ensure that you can resume this process after you're finished resolving it. It then calls the ISR. Now what does ISR stand for? ISR stands for interrupt service routine. So this will basically check the thing, and then it then calls the ISR. After I've called the ISR, what does the ISR tell you? It basically gonna resolve the interrupt. My bad, I didn't write that. So which resolves the interrupt. Once it has resolved the interrupt, the processor will then retrieve the data. The processor will retrieve data from stack to continue with the processes from the program. To continue. Now why do you need to do that? So that you can continue with the processes from the program. A very simple thing here is it basically says that if the processor will finish the fetch execute for the current process, then it will check for the interrupt priority queue. So it's at the highest part, then it stores the data of the registers on the stack, which then it calls interrupt service routine, which will resolve the interrupt. After that, retrieve the data from the stack and then continue the process from the program. Now we are moving on to the next question, which is question number 4. It says a student draws a universal enters a URL onto the web browser and a diagram to show the user entering the URL and displaying a web page. It's for 5 marks. So you get a lot of space, so let's use this space wisely. First of all, we're gonna have a user's computer. The user's computer. Now what this computer will have is basically his browser software, because that's going to be when you have typed addresses. This is basically the DNS, which stands for domain name server, DNS server or domain name server. And here you have the web server. Now the first thing that's going to happen is after you've entered the web browser software, it will send the URL. So the browser sends URL to DNS. The browser sends URL to DNS requesting for IP address of the web page. So the DNS then finds the IP address of the web page. If it does not have, it will communicate another DNS server, and once it has the DNS server 2, let's say, it'll give it back to DNS server 1, which then will store it in its cache. So what it'll return is, this is step 1. Then you have step 2, which is basically DNS returns IP address of web server. Alright, so I hope this part is clear. Now, next one you have is web server. So what you're gonna do is, now the third step, which will involve this, and the fourth step, which will again involve this. So in the third step, request sent to web server for the required web pages. The required web pages. Web server sends the HTML files. The HTML files for the pages. And then the last step is gonna be, I don't have space here, I'm sorry. So basically, browser renders, or basically translates, renders HTML files displaying their content. How this is clear, I'm going to explain it once again. So basically, first thing after I enter the URL is sent to the DNS, which will find the IP address for that URL's web server, which is sent back to the browser. The browser will send this to the web server, and the web server will send the appropriate HTML files for the web pages required. And then the computer will render the HTML files, and then it will display their content. Now let's move on to question number 5. All right. Then it says there's some I think digital currencies. So a digital currency does not exist physically. Yeah, so physically is a word here. It does not exist physically. It can only be accessed electronically. Some digital currencies have a digital ledgers, which is called as blockchains. I know this because in the textbook the word ledger is used for blockchains. So I've used blockchains as well. These are decentralized databases where each transaction is stored as a new set of data with a timestamp. Again, this is also mentioned in the textbook. So every new block created has its own timestamp and is linked to the previous set of data. This means that the transactions cannot be altered and only new transaction added, which allows the location data to be. If you see, there's only one word which matches here, trace, and basically it's again mentioned in the textbook. So because all the data is stored centrally, you can also track all of them, which allows the data to be traced. Now, I hope this is clear. It does not exist physically, it only exists in electronic format. The digital ledgers are blockchains, and there's a timestamp, and the location can be traced because all the data is stored on a central server. Now let's move on to the next question. Now we'll be moving to question number 6, which says that a self-driving tractor sows seeds and harvests crops for a farmer. The self-driving tractor moves automatically throughout the field, turning at each end and stopping when it has finished. One reason this is because it has a mechanical structure. Give another reason by the example of robot. Now robots have 3 characteristics: electrical components, programmable, and mechanical structures. Since mechanical structure is finished, I can say that it is programmable, and then you can also say that it has electrical components. Then you say that if a person is directed within 3 meters while the tractor is moving, the self-driving tractor must stop. Explain how the infrared sensor microprocessor actuators can be used to stop the self-driving tractor if the person is directed within 3 meters. So how do you answer this question? It's a very simple question. So sensors, there's a standard format for writing this question which has changed according to 2023 syllabus. So this answer I'm writing down is in the new format. Sensors continually send digitized data to the microprocessor. Sensors continuously data to the microprocessor. The microprocessor microprocessor compares the data to the stored values if the distance is greater than 3 meters, then no action is taken. Otherwise, if the distance is basically less than 3 meters, if the distance is less than 3 meters, microprocessor sends signals to actuators to apply signal to actuators to apply the brakes, which makes the tractor stop. The whole process is automatic. Now the whole process repeats. The whole process basically repeats. Until when does it actually repeat? It repeats until turned off. The whole process, not a processor, it's a process. The whole process repeats continuously until it is turned off. It's a very simple question which has been asked of in almost every paper. The microprocessor, the sensors will send the digitized data to the microprocessor, which is compared to the stored values. If the distance is greater than 3 meters, no action is taken because it's safe distance. If it's less than 3 meters, then you send a signal to actuators to apply the brakes. What do they do to make the tractor stop? The whole process will continue until the metro is turned off. Then it says identify whether sensors might be used. So I would say that you can actually use a proximity sensor. You know what? Proximity sensor. This will help tractor to detect any obstacles / objects and end of the field and end of the field. So basically the proximity sensor allows you to judge the distance. So by having such a sensor, you can know that how far an obstacle is so that you can make the right turning effects. And if there's an end, like a turn, or if you reach the end and you want to make a turning effect, so that can also be judged. Explain the drawbacks to a farmer using a self-tractor to sow seeds and harvest crops. First of all, initial investment could be expensive. Initial investment could be expensive. The second thing you have is high maintenance costs. Pretty easy question. High maintenance costs. The third thing after the high maintenance costs is basically fewer workers are required. Fewer workers are required, and when you have fewer workers, if you need fewer workers, leading to higher unemployment. That is simple. First of all, buying the tractor itself is expensive, then maintaining it expensive, and because of a tractor you will need fewer farm workers, which is high expensive. Then it says that there is a built-in expert system that farmer can use to solve any errors within the tractor. What are the components of an expert? And there are 4 of them. So there's a knowledge base, a knowledge base, a rule base, a user interface, along with an inference engine. So the knowledge base contains all the repository of the facts, the objects and attributes. The rules base contains the rules that are used to make decisions. The user interface is how the user will communicate with the system, ask the questions, and the inference engine is basically where the inference happens. So it uses the data from the user interface, which is matched against the knowledge base data, and then it uses the rules base, the rules in the rules base to actually make the predictions and providing it to the user. Then it says that at the end of each day, the self-identifier transmits the data set connected to the farmer's computer in the house. The transmission uses an echo check. Describe the role of the self-identifier in the farmer in the echo check. So you would say that data is sent from the tractor to the computer. Upon receiving, the computer sends the data back to the tractor, sends data back to the tractor. After you've done that, the tractor then compares the two sets of data. The tractor then compares the two sets of data. Okay, if they match, sends a message of accuracy, that basically correct data transfer has happened, there's no errors. Otherwise, reports error. And you can also say that and retransmits the data. In the echo check, what happens is that the data first initializes from one device and the device. The second device then sends the data back to the first device. The first device compares the sent data with the received data. If they match, no errors occurred. If they don't match, an error is occurred, and basically the data will be resent or will be reported. This is another method of checking is basically a parity block check. The table shows 7 bytes transmitting odd parity. Odd parity is used, so be careful about them. The parity bit has been completed. There's every byte has 1 bit for the parity. Complete the parity byte for the data. Simple, just 3 marks. So now for the first one, 1, 2, 3, 4. So because it's 4, we need to make it 5, 1. So basically got to do it vertically. Horizontal has been done. Got to do it vertically. There are 4, so we need to do it 5. Then you have 1, 2, 3, 4, 5. It's also no. Then again we have 1, so no. Again 1, so no. Then 1, 2, 3, 4. So 1, 1, 2, 3, 4, 5. So 0. 1, 2, 3, 4. So again another 1, 1, 2, 3. So it'll be 0. Alright, I hope this is clear. Just make it the number of ones is odd. Next question number 7. It says the data transmitted on the internet. The data is encrypted before transmission. State the purpose of encrypting data. If intercepted, encrypted. If intercepted, encrypted data will not be understandable. Will not be understandable. To whom it will not be understandable? Understandable to the eavesdropper, or let's say the hacker. It's not necessary to write this, but I'm just writing for extra information as it is given in the textbook. So encrypted data is basically not understandable because you need a decryption key. Describe the differences between symmetric encryption and asymmetric encryption. Now, first thing to talk about symmetric encryption. Symmetric encryption uses the same key to encrypt and decrypt data. Uses shared key. Symmetric encryption uses shared key. Symmetric encryption uses shared key, hence same key is used to encrypt or decrypt the data. The other one that you have is basically asymmetric encryption. Asymmetric encryption uses public key to encrypt the data, and private key to decrypt the data. So basically in symmetric encryption, the same key is used to encrypt and decrypt the data, hence it's not very secure because it easily be identified. Whereas in asymmetric encryption, there are two sets of keys, there's a public and a private key. So let's say user A wants to send encrypted data to user B. So user B will have to generate a pair of keys which will include a public and a private key. The public key will be sent to user A, which will use to encrypt the data. Then the user B will have to decrypt the data using his own private key. The data transfer using packet switching identified two items of data contained in a packet header. That would be the senders / the originators IP address, and also the receivers / the destination IP address. It says that give the purpose of a router in the route switching process. It basically sends the packets to their correct destination. Next up, what we have is basically the last question, which says that hexadecimal can be used to represent binary numbers. Convert the denary number hexadecimal into 236 into hexadecimal. So 236 needs to be divided with 16. Now I'm pretty sure that 16 into 14, so 14 5s is 70, and 14 6 are 84. 14 ones are 14, 24, 224. So 224, 234, 236, so that's 12. So 14, remainder 12. Then 16, it goes, the remainder is 14. So 0, 14, 12. Now A is 10, B is 11, so this is C. C is 12, D is 14, D is 13, and E is 14. So this would be E and C. Then it says that give one benefit of using hexadecimal numbers instead of the binary numbers to represent the data. That would be they take up less screen space. Then it says that 2's complement can be used to represent negative numbers. Convert the 2's complement 1011 to denary. So for 2's complement, the leftmost is negative. So 128, 64, 32, 16, 8, 4, 2, 1. Now just simply convert 1, 0, 1, 1, 0, 111. Okay. So if you add up them, negative 128 plus 32. So negative 118, negative 108, negative 98, and negative 96. Negative 96, then negative 86 and negative 80. Negative 76, negative 74, and hence negative 73. That should be your answer, negative 73. Then it says that convert the denary number 45 into a 2's complement integer. So again, negative 128, 64, 32, 16, 8, 4, 2, 1. But this time 45. So 32 minus 45, which will be 13. 13 minus 8 is 5. 5 minus 4 is 1. And yeah, so if you just check it again, 32 plus 8 is 40. 40 plus 44 and 45. So 0, 0, 1, 0, 1, 1, 0, 1. Alright, now moving on to the last question, which says the logical shifts are performed if high numbers complete the mathematical effect of the 4 places to the right. Now, any shift to the right basically means one shift is dividing by 2, 2 shifts dividing by 4, 3 shifts by 8, and 4. So 4 is 16. So divide by 16. How many marks is that? Okay, that's 2 marks. So divide and 16. So this is the end of the paper. I hope you guys liked the video and I hope it was helpful for you guys. Just best of luck for your upcoming May June series for all of your subjects. If you need any help, please do comment down below, and if you have any certain past paper like a suggestion for me, please do post it. It would be very great and I would be happy to make a video to help you guys. So alright, so see you in the next video. Do share this video with your friends, like, comment, share, as well as subscribe to the channel for more upcoming videos. Alright, see you then. Goodbye.